HL binomial addendum, page 6. So we're going to continue here with some combination problems. In how many ways can 4 people be selected from 10 if one particular person must be selected? Okay, so this was similar to the last problem we did with the team and the captain, for example. So if one of the particular person must be selected as part of the 4 people, then actually what we're doing is we're doing 9 chooses 3, right? Because the first person or the 10th person is already designated as part of the team. So the only thing that varies are the other 3 members of the team. So we'll do 9 chooses 3. 9 chooses 3. We'll do it on the calculator. So we'll do 9. Actually, we'll just go up and grab this. And we will delete. Fill this in. 3. 84. Okay. All right, part B. 2 particular people are excluded from every selection. So in that case, what we're saying is we're not choosing from 10 people. We're going to choose from 8 people, right? Because 2 people are designated as not being part of the choice. So we're doing 8 chooses 4, actually. Let's see what that is. Remember, these numbers are not so big that you couldn't do these by hand, right? In part C, 1 particular person is always included and 2 particular people are always excluded. Okay, so in this case, we're basically only choosing 3 people because 1 person is always included, right? But we're only choosing, let's see, out of the 10 people, 1 person is always included, so really we're only choosing from 9. And 2 particular people are excluded, so that means we're only choosing from 7. So in this case, actually, it's 7 chooses 3. Let's see what that is. 7. Oops. 7 chooses 3. Oops, not 7 chooses 43. 35. Okay. A committee of 5 is chosen from 6 doctors, 3 dentists, and 7 others. Determine the number of ways selecting a committee if it is to contain exactly 2 doctors and 1 dentist, exactly 2 doctors, at least 1 person from either of the 2 given professions. Okay. So we have 5 spots. And we want 2 doctors and 1, oops, this is kind of hard because they all start with D, don't they? So 2 doctors and 1 dentist, and then 2 don't care. Okay. But they cannot be doctors or dentists, these last 2, so that means they have to be other and other. Okay, so that means that basically we need 2 of the 6 doctors, so we could say 6 chooses 2. We need 1 of the 3 dentists, so we'll say 3 chooses 1. And we need 2 of the 7 others, so we could do 7 chooses 2. And then we just multiply these together because there's a certain number of ways to do 6 chooses 2, there's a certain number of ways to do 3 chooses 1, there's a certain number of ways to do 7 chooses 2. If you just multiply all the different ways of doing those, then it gives you every single combination. So 6 chooses 2. Let's do that on the calculator. So 15. I kind of remember that from Pascal's triangle, right? The number after 6 in Pascal's triangle is 15. 3 chooses 1 should just be 3. Because anytime you have a number and you choose 1 from it, there's 3 ways to do that. 7 chooses 2. That's probably going to be like 21 or 20 or something, from what I remember from Pascal's triangle. 21. Okay, so then we're going to do 15 times 3 times 21. 15 times 3 times 21. Oops. 945. Okay, so 945 is the answer for A. What about B? Exactly 2 doctors. So exactly 2 doctors means that we're going to have doctor, doctor, and the other 3 could be dentist or other, dentist or other, dentist or other. So to have exactly 2 doctors, we would have 6 chooses 2 for the doctors, and then for dentists or other, those 3 slots, we could choose from 10 different people, so it would be 10 chooses 3. So it would be 6 chooses 2, which is 15, and 10 chooses 3. I don't know what that is. I don't know what 10 chooses 3 is. 10 chooses 3 is 120. 120 times 15. 1,800. Okay, that was B. C, at least one person from either of the 2 given professions. Okay, at least one person, not exactly one person. We need to think about this a little bit different way. A lot of times when you get one where it seems like, wow, how am I going to do this? There's like so many different ways for that to happen. I could have one dentist and 4 doctors, or I could have 1 doctor and 3 dentists, or, there's like so many different ways to do it. A lot of times what you do is you invert the situation, and then you figure out how this doesn't happen, and then that gives you the exact opposite of what you need, and then just subtract that from the total. So let's try to do that, since this appears to be kind of complicated. So at least one person from either of the 2 given professions is the opposite of having nobody from doctors and nobody from dentists, right? That's like the opposite situation. So let's figure out how many ways there are to have no doctors and no dentists, and see how many ways that happens. So no doctors and no dentists means that we basically did not choose anyone from these 6. We did not choose anyone from these 3, and we basically only chose a bunch of people from others. How many people? 7 people from others. So basically, how many ways are there to do that? There's 7 chooses 5. Okay, so 7 chooses 5 is all the ways you can just have others on the committee and no doctors and no dentists. Now, it says at least one person from either of the 2 given professions, and basically we've created a situation which is the opposite of that. So now what we need to do is we need to subtract 7 chooses 5, and if we want to see exactly what 7 chooses 5 is, let's just do that on the calculator. 7. Oops, I didn't want to do that. 7 chooses 5. And we get 21. So we just need to subtract this from the total number of ways of getting any number of people on the committee, and basically from 6 doctors, 3 dentists, and 7 others, we know there's 16 total people. So how many ways are there of choosing 5 people from 16 total people? We'll figure out what that is. 16. Oops. 16 chooses 5. And that would be a huge number. 4, 3, 6, 8. So basically what we want is we want 4, 3, 6, 8 minus 21, which is equal to 4, 3, 4, 7. Number 11. There are 12 distinct points, A, B, C, D, blah, 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 L, on a circle. Lines are drawn between each pairs of points. How many lines are there in total, and how many lines pass through B? So basically what they're saying is, draw 12 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it says, okay, draw lines between every single possible pair of points. How many lines do you have total? And that's a pretty large number of lines. How would you calculate that using combinations? You would say, well, I'm going to choose 2 points from the 12, and I'm going to do that as many times as I can in different combinations. So that would be basically 12 chooses 2, right? So 12 chooses 2. Choose 2 would be 66. So that's the number of lines total there are. Now, how many of those lines pass through point B? Well, just think about it. You got 12 total points. Let's say the first point is B. How many points are coming out of B and going to other points? Well, there's 11 other points. So basically, you have 11 lines which go from B to another point. Right? So there's just 11. We don't even need to do a combination to do that. How many triangles are determined by the lines? So you want to pick out basically triples of points. How many different ways are there to pick out triples of points out of 12? That would be 12 chooses 3. 220. Okay, so 220 triangles can be drawn. 220 different triangles can be drawn between 12 points. And how many of these 220 triangles have a vertex terminating at B? So basically, what you're doing there is you're saying, okay, we got B as one of the vertexes. You can choose the second and third vertex from any of the remaining 11 points. So basically, what we're going to say is, how many ways can you choose 2 additional vertexes out of the remaining 11 points? So it would be 11 chooses 2. What would be 11 chooses 2? And that would be 55. And that's it for this page.